Now this is quite a tricky question. Is given that this block rests on a smooth floor. That means the block can slide here or there depending on the situation, and the string length is equal to L, while this end of the string is pulled with a constant speed v naught, or rather constant velocity v naught in vertical direction, vertically upward direction. And it is given that with how much constant speed v naught, the free end of the thread must be lifted upward so that the block leaves the floor when the thread makes an angle theta with the floor. Acceleration of free fall is g. So let us look at the situation when the block leaves the floor. So here, suppose the block leaves the floor. The block leaves the floor at this situation. This is the situation drawn in the figure. So surely the acceleration of the block is along this direction, because in vertical direction it is just this. What happens? This normal reaction is equal to 0. So let us see what are the forces. These forces are tension and this mg, and what we will do is that here we will shift to the frame of this point, the free end. Why we will shift to this frame? Because as this is moving with a constant velocity, this becomes an inertial frame of reference. So from this frame we will analyze the problem. So let's this be the frame of reference and this is the block. So with respect to the frame, obviously the block will have a velocity this way, obviously, because with respect to the frame, this fixed point, this is the length, so block obviously will have a velocity this way. And we know that as see from with respect to ground, actually this block is at rest and this end has velocity v naught. So with respect to this point, the downward velocity of this block is v naught. Remember that. With respect to this point, again I am telling, the downward velocity of this block is v naught. So that means the relative velocity of block is v. So we'll make the component of v. This component of v is v naught. So this is again theta. So v naught we can write v naught is equal to v cos theta. Remember that this v is velocity of the block with respect to the free end of string, because with respect to the free end the block will be in circular motion, because there is no other option. If this length is fixed with respect to this one point, obviously it will be either at rest, or if at all any motion exists, it ought to be circular motion. Okay, now so the absolute acceleration of the block is this way. Even with respect to this inertial frame of reference, also the acceleration is a. So the acceleration has component this a cos theta, and this component is equal to a sin theta. And here at this moment I'll just tell you about the forces. So forces means tension and this mg, and obviously this is equal to so the mg cos theta. So mg cos theta, and this is equal to mg sin theta. So we can write this. So the acceleration, again the component is equal to a cos theta, and this tangential component is equal to a sin theta. So we can write for the tangential component, with respect to the fixed point, this a sin theta, tangential acceleration, is equal to mg cos theta. So that's an equation. And also we can write a cos theta, centripetal acceleration, that is v square by L. So let's see, from these three equations you will get the value of v naught. Then what we'll do here is that we will just divide these two equations. We will divide these two equations and find here this will be uh, sine theta divided by cos theta, or rather we'll do like this: cos theta divided by sine theta. Cos theta divided by sine theta is v square divided by L sorry, this will be an A, right? So ma sine theta is in GS. So v square divided by Lg cos theta. So therefore, and again from this equation we will replace here v naught in place of v. So therefore cos theta divided by sine theta is equal to v square, means v naught square by cos square theta Lg cos theta. So therefore this v naught is equal to cos square theta square root of gl divided by sine theta. So that's the answer, that is the solution. So it's a way to solve problems whenever you see this type of a thing, that this point moving with a constant velocity. So it is obviously an inertial frame of reference, and you can be able to solve problems from this frame.